Okay, we're going to start with neural tube formation. Okay, neural tube is going to be your nervous system, your CNS eventually, and neural tube formation starts at day 21 in the embryo. Okay, what you see here, there are 4 different pictures. I'm just going to go through 4 different stages. Up top here in the top left-hand corner is going to be the first stage that we're going to talk about. And we're going to progress through a series of things to end up with the neural tube at the bottom. So, start here. Around day 21 in the embryo, which isn't very long, you have a structure that looks something like this. This is the future baby. Okay? And the future baby has a couple of different parts that you need to be aware of. This topmost layer, 3 different layers here. The topmost layer is known as your ectoderm. Ectoderm, all the things in this structure will eventually create the central nervous system, the peripheral nervous system, and skin of the baby. Okay, all those things, PNS, CNS, and skin, are going to be derived from the ectodermal layer. Then you have your middle layer. Your middle layer is known as your mesoderm, M-E-S-O-D-E-R-M. So your mesoderm, or the middle layer, will eventually become the muscles and skeleton of the embryo. And the lowermost layer here, this structure, is your endoderm. E-N-D-O-D-E-R-M. And your endoderm will create the future, essentially, GI system. So if you can imagine, what's going to happen is that this structure is going to end up folding over on itself, so that on the outside, the ectoderm is all around the outside, so that's your skin, your CNS, and your PNS. Your mesoderm, muscles, and skeleton just under that, and then your GI system, essentially, is going to be on the very inside. Okay, so that's what's going to happen. Other things that you need to be aware of are this structure up here. Okay. This is known as your prechordal plate. So your P-R-E-C-H-O-R-D-A-L plate. Already at day 21 in the embryo, you know rostral from caudal because the prechordal plate represents the future mouth of the baby. So this is rostral up here, down below is caudal. And there's a structure here that resides in the mesodermal layer, or the middle layer, and what you see here is just a cross section. So this structure actually goes all the way through, all the way up to the prechordal plate, and this is called your notochord. Notochord. It's your notochord. Okay, so the notochord resides in the mesodermal layer, and it goes all the way through, all the way up to the prechordal plate. What happens is, and this is all about day 21. This is the first step. We're going to move to the right to get to the second step. This is the second step over here. And what happens is the notochord releases growth factors. Has anybody ever heard of growth factors before? Yeah. Can you name one? Name a growth factor. Any growth. No? No taker. You heard of them before. You've never heard of one? All right. That's fine. I used to work with growth factors, so just curious. Okay. So notochord releases growth factors, and what happens is they're released from this structure, and they actually migrate upward to the area of the ectoderm. Okay, and when they do that, what happens is that this area right here in the ectoderm starts to grow. It gets a whole bunch taller. Let's do purple. So this is the area that overlies this notochord here that's in the ectoderm, that because of the release of growth factors by the notochord, it starts to grow and develop, and it gets a little bit taller than the rest of the surrounding ectoderm. So again, you still have your prechordal plate. You have your notochord. Bless you. Release the growth factors that cause this it's a thickening in the area of in the middle of the area of the ectodermal layer. Okay, this thickening has a special name. It kind of looks a little square. It's called a neural plate. Plate. That's your neural plate. A neural plate is nothing more than a thickening of the ectodermal layer due to release of growth factors by the notochord. Okay, that's the second step, formation of the neural plate in the ectoderm. And then going across here, coming out over here, the third step is going to be this picture in the bottom left-hand corner. Still have your prechordal plate. Still have your notochord. And your three different layers, endoderm on the bottom, mesoderm in the middle, ectoderm on the top. But what I'm trying to show here with this picture is that the neural plate starts to collapse in on itself. So if this piece of paper were the neural plate, what happens here at step 3 is that it starts to form a groove. Just like that. It folds in on itself. So it starts to collapse down. Okay. And nothing fancy here. What this structure is called is the neural groove. So you go from your plate to your groove. And then going from step 3, last step involved in the creation of the neural tube. It's going to be the 4th step. Again, Rostrally, you have your precordial plate. And you have your node cord that goes all the way through. And now what happens is the neural groove, it's collapsed in on itself, and then as time goes on, it actually folds over to form a tube. Okay? And cells at the very top of the tube kind of fall off and go to the side. So not surprisingly, this structure here that folds in, the neural groove continues to fold. This structure is your neural tube. And your neural tube is going to be your future CNS, or the baby's future CNS. And bless you. Like I said, you have these little cells here that, I mean, as the neural tube is being formed, some cells fall off the top and slip over to the side. These are called your neural crest cells. Okay, so each of these little dots here on the side, these are just cells that fell off the top of the forming neural tube. And your neural crest cells are your future PNS. The rest of the ectoderm is going to be your skin. And if you see, as the neural tube is forming and it comes all the way around and becomes a full-fledged tube, it has a hole in the anterior and posterior portions. So there's a hole right here in the top, and then there's a hole right here in the bottom. And these are just empty spaces right now. Okay. The empty space on the anterior portion, or the most rostral portion of your neural tube, is called your anterior neuropore. Essentially, this is the space where once it closes, the brain's going to start to develop. Okay, and down here, this other space, empty space at the bottom of the neural tube, is going to be your posterior neuropore. And neuropore is nothing more than just a word for a hole at the end of the neural tube. And there's one on the anterior end and one on the posterior end. And what's going to happen eventually is, if all goes well, the posterior neuropore and the anterior neuropore are going to close up. Okay, does anyone know what it's called when the posterior neuropore doesn't close properly? Not cauda equina. Cauda equina is going to be, that's not horse's tail, right? There's cauda equina syndrome. That's a problem, but it's a common problem with babies. Spina bifida, right, good. So if the anterior neuropore doesn't close properly, the infant will develop spina bifida. Lots of different kinds of spina bifida. There's different levels of severity. You will cover those different kinds in PEDS next year, next fall. Okay, does anybody know what the mother can do to help prevent spina bifida? Folic acid. Supplement with folic acid, very important. Okay, you don't want to, spina bifida can be a big problem. There's even more of a larger problem if the anterior neuropore doesn't close properly. Does anyone know what that's called if your anterior neuropore doesn't close? It's at the opposite end. So spina bifida is usually lumbar level. Anybody? No? It's called anencephaly. I'm gonna put that down here because I don't. A-N-E-N, anencephaly, S-E-P-H-A-L-Y. And anencephaly, unfortunately, if the anterior neural pore doesn't close, then the brain is not formed. So the infant is born without a cortical region and no skull over top. It's just skin over top of the brainstem. And that's not compatible with life. Okay, so really important. If you're thinking about having a baby, make sure you take your folic acid. Anencephaly, not a good thing. Spina bifida, still not a good thing. Questions about that? You guys heard of anencephaly before? No? Okay, well, it's a real thing. Any questions? Any questions? Okay, this is pretty much what we need to know about the nervous system formation. It starts at day 21, which is really, really early. Okay, so important to start supplementation and have a really good diet before you get pregnant. All right, moving on. Now, at about day 28, so neural tubes start to develop at about day 21. By day 28, the brain starts to form. Okay. So we're going to look at the brain formation first. So what I have pictured here is the neural tube. So I've just taken the neural tube out of the ectoderm, and I'm just showing you the neural tube here. Okay, this is from the previous picture. I've just picked up the neural tube. Neuraltube. Okay, that's going to be the first place where we start. Question?
So by day 28, that's when it starts forming?
By day 28 is when the brain starts to form.
And then day 21 is when the neural tube starts forming?
Day 21 is when neural tube starts to form, correct. Yeah, so what happens is that anterior neuropore, which was way up here, closes and the brain starts to form, as long as there's enough folic acid around. Very important. Starting at day 28 with a fully formed neural tube, we're going to progress to the right. Okay, and this neural tube, the neural tube itself, it's still a tube. It's still hollow inside, right? You've got this hollow space inside. And then at the rostral end or the anterior end, whichever you want to say, of the neural tube, you start to have 3 bulges form. Okay, these 3 different bulges are known as your primary brain vesicles. So go from the neural tube, when the anterior neural port is fully closed, you start to develop 3 different bulges, and these bulges are collectively known as your primary brain vesicles. 3 different ones that we need to know about. The first one, most anterior, it's called your prosencephalon. Prosencephalon. Prosencephalon, most anterior. Okay, so your first primary brain vesicle is your prosencephalon. Your next primary brain vesicle is your mesencephalon. mesencephalon. Your mesencephalon. Okay, primary brain vesicles, prosencephalon, mesencephalon. The bottommost one is known as your rhombencephalon. A-L-O-N.
Can you spell that one more time?
Uh-huh. Rhombencephalon. R-H-O-M-B-E-N-C-E-P-H-A-L-O-N. So 3 different primary brain vesicles. Prosencephalon on top, mesencephalon in the middle, rhombencephalon is in the bottom. Okay? These are nothing more than 3 different swellings that happen off the anterior end of the neural tube. Primary brain vesicles are first, 3 different ones, and then over to the right, we have the formation of your secondary brain vesicles. Okay. The prosencephalon, this primary brain vesicle here, starts to swell. Okay, that swelling becomes the topmost portion here. So this prosencephalon will swell into 2 different areas. Okay, the first area is going to be this top area here. The prosencephalon becomes your telencephalon. Okay, so in your telencephalon is nothing more than this topmost area here. Your telencephalon is the future lobes of the brain. In the future cortical region. Right, so you have your frontal, parietal, occipital, temporal. There's an history too. Okay, that's your telencephalon. So from your prosencephalon, starts to swell, creates a large swelling here known as your telencephalon, and those are future lobes of the brain. The prosencephalon also has a second area of swelling, and that's this area here. And that's just under your telencephalon. Okay, this is known as your diencephalon. D-I-E-N-C-E-P-H-A-L-O-N. So your diencephalon. And your diencephalon houses the future thalamus and hypothalamus. That's your diencephalon. So both brain cortical region as well as your thalamus and hypothalamus come from the primary brain vesicle. That's your prosencephalon. Prosencephalon splits into the telencephalon, cortical region, and the diencephalon, which is thalamus and hypothalamus. The mesencephalon, this middle swelling here that was the primary brain vesicle, doesn't really change at all. It just kind of hangs out there, so we'll label it, and it's still called the mesencephalon here. Okay, so that's going to be this region, the brain. So no big changes between your primary brain vesicle, mesencephalon, to your secondary brain vesicle, mesencephalon. Just kind of goes along for the ride. And the area where you're going to see the biggest change is in your rhombencephalon. Your rhombencephalon splits, this primary brain vesicle splits into 2 different regions. One here. Okay, it's going to encompass, it's going to become this region here. So your rhombencephalon splits into what I've labeled as the purple there, and this is now known as your metencephalon, M-E-T-E-N. Your metencephalon. And then your rhombencephalon, in addition to the metencephalon, also has a lowermost swelling here that is your myelencephalon. M-Y-E-L E-N-C-E-P-H-A-L-O-N, myelencephalon. Okay. So, primary brain vesicles, prosencephalon, mesencephalon, rhombencephalon. Secondary brain vesicles, prosencephalon becomes telencephalon and diencephalon, or your cortical region in your thalamus. Your mesencephalon stays as the mesencephalon, no change. Okay, rhombencephalon swells in two different regions, becomes two different secondary brain vesicles. One, the uppermost one, just under the mesencephalon, is your metencephalon. Underneath that, you have your myelencephalon. Okay, so we're forming the future brain. Yes.
So would you say the middle bulb of the three is still the rhombocephalon, but it just has those two extensions because you have like three in a row there? Are they all metacephalon?
They're all metencephalon. They're all so they're all part of the secondary brain vesicle known as the metencephalon.
Okay, perfect.
And like I said, remember that these areas inside the main swelling of the neural tube are still hollow. So since you're getting all these swellings, in addition to the swelling, you're also getting the formation of the ventricles in the ventricular system. All right, so you have your lateral ventricles and your third ventricle are going to be up here, derived from this prosencephalon. You're going to have your cerebral aqueduct, you're going to have your fourth ventricle here, and then down below you still have the central canal going all the way through the spinal cord. So everything's hollow inside yet. Secondary brain vesicles, we go to the right. This is going to be the fully formed brain. Okay, so your telencephalon, like I said, is going to be here, and it's going to be your cortical region. And, sorry? So so your future lobes of the brain, or your cortical region, is your telencephalon. That'll eventually ends up here. The diencephalon kind of collapses in on the telencephalon to form the thalamus. So here's your diencephalon, your thalamus and your hypothalamus. End up here. Your mesencephalon hasn't really changed here in your secondary brain vesicles, but it becomes your midbrain. Okay. Your metencephalon forms a couple of different structures. The first is going to be your cerebellum. Okay, and the other structure that comes off the metencephalon is going to be your pons. And your myelencephalon, secondary brain vesicle, comes over to become your medulla. everything lower down is simply your spinal cord. So starting out day 21, you have your neural tube that's formed. Anterior neuropore for the neural tube closes at about day 28. And then 3 different swellings happen: prosencephalon, mesencephalon, rhomencephalon. Prosencephalon becomes the telencephalon. And then the telencephalon eventually becomes the cortical region of the brain. From the prosencephalon also you get the diencephalon. That becomes the thalamus and hypothalamus. And then moving on down, you have your mesencephalon, primary brain vesicle, still the same as the secondary brain vesicle, and it doesn't change a whole lot after that. It just becomes your midbrain. Okay. Underneath your midbrain is your originally rhomencephalon became your metencephalon and myelencephalon. Metencephalon eventually develops to become the cerebellum as well as the pons. And then the myelencephalon becomes your medulla. Question? Jeremy?
So, once you get to your primary brain vesicle, is that when it turns into the spinal cord part, or is it just at the very end where it's on the lower part of the tube?
We're going to do the spinal cord here in a minute.
Okay.
Haven't got there. Yep, it's got to wait. So they both happen at about the same time, but I usually like to show you the brain formation first, and then we'll do the spinal cord here in a minute. Yes?
How long is from neural tube to the brain? Is that period that takes?
20, it's another week maybe, so it's 35 days or so within the first month. Yeah, brain's formed very quickly. The nervous system is formed very early on in the embryo. Okay. Any other questions? And like I said, this is just brain formation. Here in a minute, we're going to go to the next slide and we're going to look at spinal cord formation. But this all comes from the neural tube. The neural tube all came from your ectodermal layer. Okay, so from your ectoderm, you have your neural plate, and you have neural groove, and then your neural tube forms. Okay, the neural tube has the neural tube part plus the neural crest cells. We're going to look at the neural crest cells here in a minute. The upper part of the neural tube is where your brain forms from. Everything down below happens simultaneously, and it's going to be the formation of your spinal cord. Questions? All right, let's move on. Last one. This is going to be your spinal cord formation, which, as I said, happens about the same time. At about day 28 in the embryo, you start to form your spinal cord. When I showed you the here, when I'm looking at the neural tube, I'm showing you a long view or an anterior view, posterior, any way you want to look at it, and really anterior because cerebellum's in the back. Okay, what I'm going to do is I'm going to take the neural tube and I'm going to cut it in cross section. Okay, here, this here is just a cross section through the neural tube. So it's a neural tube cross section. Well, if this is a neural tube cross section, what are these little dots up here? Does anybody remember what they're called? Yeah, those are your neural crest cells. And I'll even put neural crest PNS. In the spinal cord. And this is really a cross section of the neural tube, which is going to become the future spinal cord. Right here in the center, you still have this empty, well, it's really fluid-filled space. Does anybody remember what that's called in the spinal cord? What's that? That's your central canal. It's been there since the beginning. black. Okay. You have your central canal in the very middle of the cross section. On the outside of the central canal, you have bundles of gray matter, gray cells here. These are neuronal cell bodies that have formed. This is known as, just right around the central canal, it's called your mantle layer. M-A-N-T-L-E. Your mantle layer. That area is just a bundle of neuronal cell bodies that are surrounding the central canal. And your mantle layer is going to be your future spinal cord gray matter. And so you have the central canal, then you have your mantle layer. Then outside your mantle layer, you have a whole bunch of white matter. And this white matter is known as your marginal, M-A-R-G-I-N-A-L layer. And that's your future tracks, white matter. Just say future white matter. Okay, so you have your central canal in the middle, you've got your mantle layer. On the outside, a whole bunch of neuronal cell bodies that are surrounding that central canal. And then outside of that, you have extra white matter. There's lots of white matter there that doesn't have a destination yet. That's called your marginal layer. And this is what exists at about day 28. Now moving to the right here, we're going to consider what happens. And I'll here's your central canal here in the middle. Okay. And these neuronal cell bodies here that were surrounding the central canal, they start to divide. They start to divide very rapidly, and they actually form a structure that looks kind of like this. And this structure is filled with neuronal cell bodies. So these just came from the mantle layer, and they start to rapidly divide and form kind of a butterfly wing kind of structure. Okay, bilaterally. And this is nothing more than neuronal cell bodies that were surrounding the central canal have rapidly divided, formed this structure. That's on top. And then a similar situation that happens on the bottom. Neuronal cell bodies have divided to form two more wings on the bottom, and these are nothing more than neuronal cell bodies that exist inside this structure. They've rapidly divided bilaterally to form a butterfly shape.
That's from the marginal layer.
This is all from the mantle layer. So the neuronal cell bodies these are all the neuronal cell bodies that are part of the mantle layer. And those neuronal cell bodies have just started to divide and expand out, up and down and left and right. Okay. If you think about spinal cord cross section, these blue neuronal cell bodies have a name. They're known as the alar or association plate. Okay, your alar or association plate. And these are the future neuronal cell bodies in the dorsal gray horn. Okay, so your future dorsal gray horn stems from your mantle layer. Okay, neuronal cell bodies. Mantle layer rapidly divides, becomes something known as your alar or association plate, which will eventually become your dorsal gray horn. And similarly here down below, we have these neuronal cell bodies. This is called your basal, B-A-S-A-L, or motor plate. And these are future ventral gray horn. And we also have around the outside this white matter will become your future tracks. And you have here on the sides your neural crest cells. Now these are neuronal cell bodies. These neural crest cells up here, these are neuronal cell bodies that I said were going to become your peripheral nervous system. So what do you think lives here? Yep, that's your dorsal root ganglia. So if we had to put that in, come here and here. All right, so there you go. And these are nothing more than your dorsal root ganglia that houses first order sensory neuron. Cerebropolar. Questions? That's your spinal cord. That's where it comes from. And that's really all you need to know as far as embryology is concerned to be a PT. No questions? Pretty easy? Okay, let's go ahead and